Alright, so today we're doing some more trig graphs. Today we're just going to do tangent. Cotangent, we'll do cosecant and secant tomorrow. But as a warm-up on your calculator, graph the tangent of x. Make sure your calculator is in radians, otherwise it will not graph correctly. Once you're done with that, you should get a graph that looks something like this. These are your asymptotes that I'm drawing in, and these should be at pi over 2 and negative pi over 2. So looking at this, we have to think about what is the period for tangent of x. It's going to end up being pi instead of 2 pi because our cycle here is from negative pi over 2 to positive pi over 2, which is a length of just pi instead of 2 pi. So some characteristics to remember for tangent is you want to have a period of pi as your standard. There are asymptotes at negative pi over 2 or pi over 2, and that's also like half your period. So if your period was 2 pi, your asymptotes would be at pi and negative pi, and then at 2 pi, and then 3 pi, and then 4 pi, etc., etc., etc. Again, you still want to divide your period into 4 even parts like we've been doing with everything else. You're going to start with your asymptote, and then negative 1, 0, positive 1, and then an asymptote, and then negative 1, 0, positive 1, asymptote as you keep going along. All right, so how can we use the unit circle to explain why the tangent has asymptotes versus just regular values? You can think of right here at 90 and at 270, we list tangent values, tangent 0 here and 0 here, but it's undefined at 90 and 270. So when you're graphing it, you're going to end up getting asymptotes at your undefined values. So our answer to the first question is your undefined at 90 and 270, or pi over 2 and 3 pi over 2. So why do a period of pi instead of 2 pi? If you look here on this chunk of your unit circle, your tangent values are going to start repeating. So here your x and y are the same, and x and y are the same, like right here and here. So you're going to end up getting the same tangent value across from each other. So rather than repeating every 2 pi, you're repeating every pi. So how would we graph one of these? So your amplitude is going to be 2 from this. Your period, instead of doing 2 pi divided by your value, you want to do pi divided by this, which then is going to translate into 2 pi if you multiply by the reciprocal. So to sketch your graph, take half of your period on either side of 0, so pi and negative pi, and mark your amplitudes. And we want an asymptote first, and then at negative 2, 0, positive 2, asymptote, and connect, and you get something like this. And you can keep going, you can graph more than one period, but that's all you really need to graph. So then cotangent, graph it in your calculator and look at tangent as well and see what are the similarities, what are the differences. You should be getting that they are the same basic shape, but differences is cotangent is flipped from tangent, and tangent goes through 0, 0, but cotangent doesn't. So in the graph of cotangent, things to remember. The period is still a standard pi. Your asymptotes are now at 0 and pi, or at your period markers. So at 0, pi, 2 pi instead of pi over 2 and negative pi over 2. And then the pattern is still the same. So you still start with an asymptote, but instead of going at negative 1, you start at positive 1, 0, negative 1, asymptote. So it's flipped from tangent. And that's it for today. The rest of these we're going to do tomorrow, so you can ignore them for now. And your homework is going to be the 4.5.1 worksheet on Schoology.